Hello, I'm Mayank Tyagi, and I'm a professor at Kraft and Hawkins Department of Petroleum Engineering, as well as I have a joint appointment with Center for Computation and Technology. And my area of expertise and specialization is in computational fluid dynamics. I do research in the area of developing software that can help solve engineering problems in the area of mechanical engineering, biological engineering, or from CCT's aspect, and also developing reservoir simulators for petroleum engineering application. Some of our projects are also dealing with coastal modeling, and we are currently developing the software that can help understand these coastal processes a little bit better. Fluid dynamics, as the name would suggest, is basically study of fluid in motion. And most of your processes in, say, chemical industries or aerospace or automotive, and now in the area of biomedical engineering, typically try to understand either the heat transfer in an exchanger or mixing in some kind of a reactor. And these are pretty complicated systems. You would like to basically understand some fundamental processes or optimize their designs through some kind of simulation. And using these mathematical governing equations for this phenomena, you can write down computer codes and then use this ever improving computer hardware to solve these problems in a reasonable amount of time. And that is, in a nutshell, your overview of computational fluid dynamics. Here at CCT, we are developing some of these physics modules within this cactus framework, which has traditionally been used by numerical relativists to see the evolution of black holes and supernova events, or neutron stars for that matter. So what we are trying to do is use that infrastructure, put in our physics equations in there, and then run it on supercomputers and try to tackle some problems of interest to various disciplines. So that's the motivation for computational fluid dynamics toolkit. We are also collaborating with projects like reservoir simulators in petroleum engineering area, and storm surge simulators, or dispersive wave simulators in the area of coastal modeling in the context of CFD Toolkit also. The projects dealing with reservoir simulators are under a big umbrella of what is called UCOMS project, or Ubiquitous Computing for Marine Systems, is spearheaded through University of Louisiana at Lafayette. And Professor Chris White, Gabriela, and myself and Professor Juan Lorenzo are in the LSU team, and of course Professor Tefik Kosar from computer science. We are from the LSU team. My role in that particular team is to develop these reservoir simulators that can scale and use these high-end computer resources that we have been deploying using Lonnie and Queen Bee, Tezpur, all these supercomputers we have accumulated over the years, and try to run reservoir simulators that use them very efficiently. One of the scenario in that project is actually using an ensemble of reservoir models and run them over. Each reservoir model is a parallel simulation, and you're launching all these parallel simulations on distributed resources, or even on a single machine, lots of such simulations running simultaneously, and update the parameters in each run from the real-time data. That could be coming either from an experiment or some field, and in that sense it's kind of a unique, one-of-its-kind project, and we are pretty excited about actually developing such a project and combining it with an statistical optimization in it. So it's a pretty unique project.